Okay, thank you for joining us on this Year 12 M1 support session. We're going to look at a question to do with inclined planes, equilibrium. So the question we've been asked today is, here we have an inclined plane and we've got a 2 kilogram mass. So let's go through the question and see how we can solve this. A box of 2 kilogram is held in equilibrium on a fixed, rough inclined plane by a rope. The rope lies in a vertical plane containing a line of greatest slope of the inclined plane. The rope is inclined to the plane at an angle of alpha. So when we see a rope inclined at a plane that's not parallel to the plane, what we've got to now realize is there's going to be a component up the plane of that rope. Let's just put T for that tension. And there's going to be a component that's going to be going directly north of perpendicular to the plane as well. So we've got this two components of distance here. The rope is, the angle is at 3/4, is it? So tan of alpha is opposite over adjacent is 3/4. And knowing our triangles, we've got a 3, 4, 5 triangle. Then that will help us if we have cos or sine later. Coefficient of friction between the box and the inclined plane is 1/3. So if the coefficient of friction is 1/3, we've got this, whatever the downward component of our force is, we've got 2G going directly down. If that's 30, that's 60, that's 30. So this is going to be 2G cos 30. The box is on the point of slipping up the plane. All right, slipping up the plane. So there's enough tension in the string to make it almost move up the plane. So we've almost got movement up the plane. Now if the movement is almost about to move up, it means our resistance force is greatest down the plane. So we've got the resistance force is at the maximum point. And there is a formula for maximum resistance. It's mu times m, which is 1/3 times n. By modelling the box as a particle and the rope as a light inextensible string, find the tension in the string. What we will do is we will resolve the forces in two directions. We will resolve the forces in the direction of the plane, as in down the plane and up the plane, and we will resolve the forces perpendicular to the plane. And we will call that our up, we'll call that our down, we'll call that our left, for want of better words, we'll call that our right. And we'll come up with two equations. The first equation, let's let the up equal the down forces. So our up forces are, we've got N, we've got T. Now if that's alpha, down, this is T cos alpha, up to the right, and this would be T sine alpha, up the plane. So we've got a force up of T sine alpha. And our forces down is our weight component downwards. So if that's 2G cos 30, and we've already written that here, our down force is 2G cos 30. We've got two variables here, and well, let's just let that equal 1 for now. Our force, let's look at our left equals the right forces, and then take stock after that. Our left forces, we've got two forces down the plane. We've got our maximum R, which is 1/3 N. That's our force down. We've got our force down due to gravity, so if that's 2G, This would be 2g cos 60, 2g cos 60 plus 2g cos 60. That's our two forces to the left, and to the right, in this case up the plane, will be only one force to the right, and that is t cos alpha. T cos alpha. From our triangle, tan of alpha is 3 over 4, sine of alpha will be 3 over 5, and cos of alpha will be 4 over 5. So let's just replace in our formula, let's just go t plus 3 over 5t equals 2g cos of 30, and that is sine of 30 is a half, cos of 30 is root 3 over 2, root 3 over 2. Here we have 1/3 n plus 2g. Cos of 60 is the same as sine of 30. Cos of alpha is 4/5. All right, so using our two equations here, we could use substitution or elimination. Since we've already got t here, we could say 5 over 4, 1/3 n. This may not be the easiest way to go. Let's replace t over here with 3/5, 5 over 4, 1/3 n plus g equals root 3g. Right, don't let the algebra scare you. Let's just let's work with it. N plus 3/4 of a third is 1/4 n, and 3/4 of g equals root 3g. So we've got n plus 1/4 n is 5 over 4 n equals root 3g minus 3/4 g. Let's find out what n is. We pick up our calculator at this point and let's do the calculation. Square root of 3, so 3 to the power of 0.5, square root of 3, minus 0.75, and multiply that by 9.8. So we've got 9.264 times 4 over 5. Did I write that down correctly? I'll just double check that. I have been known to sort of mix my numbers around. So if I factorise that, take away 0.75, times that by 9.8, 9.624. No, it's 9.624. There you go. I didn't write that down. 9.624. That would help. Silly mistakes emerge as we do this. (9.624) times by 0.8. Now we've got a 7.6992. Now that's for n, and if we substitute n up here, 5 over 4, 1/3 of 7.6992. Let's see what we get for t. So 1.25 times 7.6992 divided by 3 plus, and then 9.8 times 1.5, 9.8 times 1.25, 1.25. and we get 15.458. 15.458 newtons per T. Now, I may not have done the mathematics the easiest way. I've just used substitution. Perhaps if I had gone back to this equation and used elimination, we may have ended up with a lot of simpler mathematics down here. But you can do that as an exercise. I've used substitution. Try elimination on this and see what you get. But let's hope you get the same answer as I did, 15.458 newtons. And I've got it on good sources that is actually the answer we're supposed to get. So thank you for joining us with this support session. I hope that you're able to tackle this question on your own on an exam. Until I see you or talk to you next, stay happy.